Linear functions is what's up next. We have a function whose graph is a line. We call that a linear function. It can be written in the form y equals ax plus b, or f of x equals ax plus b. A and b are constants. Now, if x and y are in separate terms in an equation and each is raised to the first power and not in a denominator, then the equation can be written in that form. We just solve for y. That means it's a linear function. Recall that x and y can be replaced by any other variables. Remember, when we have coordinates in the plane, we call them x, y. If we're using other variables, we just make sure that they're in alphabetical order, and that way you know what variable is standing in for the independent variable and which variable is the dependent variable. So in example 1, we are to determine whether each equation represents a linear function, and then if it does, give the domain and the range. So for this one, we have s and t instead of x and y. Alphabetically, it's s, t. So we need to solve for t just like we would have solved for y up here. So let's go ahead and subtract 2t from both sides and then divide by -2. So this is the equation that we get. We were able to put it into that form. There are no exponents. We don't have our s in the denominator. So yes, this is a linear function, and you can even put that in on your graphing calculator if you like and see that it's a straight line. The domain, since this is a linear function, is going to be -infinity to +infinity, and the range is -infinity to +infinity. It's not true that the domain and range is always that. You'll see here on this next example I have y equals 5. You might recall that that is it's a horizontal line. If not, you can go ahead and graph it on your graphing calculator. Go into y equals, put y equals 5, and just zoom standard. You can see it's a horizontal line going through the value of 5 on the y-axis. So we have here a domain. We say yes, it is a function. It's a linear function, and the domain is from -infinity to +infinity, but on the range it's only ever 5, a single value of 5. So we don't use interval notation. We throw back to the roster notation and just note the value 5 in there. On part C, xy equals 2, I'm going to solve for y by dividing by x. And here we have x that's in a denominator. So this is not going to be a linear function. In fact, if you want to see what kind of a graph it gives you, you can put that in on your graphing calculator. 2 divided by x. Graph that and you see it's definitely not a straight line. X equals 3. You may recall that that is a vertical line. Just like y equals 5 was a horizontal line, this is a vertical line, but there's no way to put that in on your functions in calculator because these are all y equals. There's no y in that. So it's not a function. It's not a function. It's definitely not a linear function. So again, we don't need to find the domain and range since it's not a linear function. If you were to graph this, you would have just a rough sketch here, you would have a vertical line like this, and guess what? It doesn't pass the vertical line test in order to be a function. So if it's not a function, it can't be more specifically a linear function either. Intercepts are points where the graph crosses or touches the x-axis or the y-axis. We call them x-intercepts and y-intercepts respectively. And an x-intercept of the graph of the function is also called a zero of the function. We'll get into that more later on in the course. But let's first talk about the x-intercepts and y-intercepts. X-intercepts are found by staying on the x-axis here. So at for any graph, the x-intercept, they're all going to have the same characteristic, that the y part is 0. So maybe this is -6, 0, this is -1, 0, this is 1/2, 0, this is 3, 0. So we have some kind of a number here, and the y part is 0. So if you want to find an x-intercept, force the y to be 0 in the equation and solve for the x value. So you figure out what the x value is when y is 0. Likewise, y-intercepts, they're going to be making the making the x 0 and make the y some kind of a number. So you see all the y-intercepts on here. The thing they have in common is that the x part is 0. So finding a y-intercept, you first force the x to be 0 and then solve for the y, and that gives you that coordinate. Make sure that you are always writing these as coordinates. They are coordinates, and it will help you immensely when you have to interpret the problem in terms of that application. So let's find intercepts algebraically. We have this graph of the equation 2x minus 3y equals 12. So if I want to find the x-intercept, this is actually quite easy, because remember, finding the x-intercept, we make the y 0. If I do that, wouldn't this entire term go away, because it's 0 times the -3? So this just all goes away, and then I'm left with the equation 2x equals 12. Therefore, x is 6. So I am able to find that pretty quickly just by covering up that one term. You can just do it with your finger. I'm scribbling through it on my ink pad here. Okay, and for the y-intercept, again, it's set up perfectly for this. Y-intercept, we're going to make the x 0 so that we stay on the y-axis. So here we go, cover up with your finger that first term. Don't cover up the negative, make sure that's showing. That goes with the 3y term. So we have this equation of -3y equals 12. You divide both sides by -3 and you get a y value of -4. So there is your y-intercept. When we go to graph this, we are going to graph with the intercepts. So we have 6, 0, and 0, -4, and then we go ahead and go through those 2 points that we've made, and make sure you put arrows on the ends that shows that it goes from -infinity to +infinity. That's it. For example 3, we have loan balance. This is something pretty common. You'd see this in a business class. We have a business property purchased with a promise to pay off a $60,000 loan plus the $16,500 interest on the loan by making 60 monthly payments of $1,275. The amount of money, Y, remaining to be paid on $76,500, which is the loan plus the interest, is being reduced by $1,275 each month. Although the amount of money remaining to be paid changes every month, it can be modeled by this linear equation. Y equals 76,500 minus 1,275x, where x is the number of monthly payments made. So we recognize that only integer values from x from 0 to 60 apply to the problem, but we can go ahead and connect those points with a line to kind of emphasize what that trend is. So first we are going to find the x and y-intercept of the graph of the linear equation. And sure, you could do this on your graphing calculator, play around with it, but we're going to find it algebraically so that we can use the calculator more efficiently. So the x-intercept, we're going to make the y 0 and solve. So we're going to add 1,275x to both sides. And we're going to divide. So 76,500 divided by the 1275. 60. So my x-intercept is 60, 0. The y-intercept, we make the x 0, and so I have y equals 76,500 minus 1,275 times 0. That multiplies together and goes away, so we get a y equals 76,500. Again, that's not your y-intercept. That's just the number that you get for the y when you're finding the y-intercept. So we write the y-intercept as 0, 76,500. All right. Interpret the intercepts in the context of this problem situation. At this point, I think it's a good idea for you to specifically write out what the x and the y represent for every point in this function. We already underlined x is the number of monthly payments made. So x is the number of monthly payments made. And what is the y? The amount of money remaining to be paid is being modeled by this. So that's what the y is. The amount of money remaining to be paid. There we go. So when we are interpreting the x-intercept, we have a 60 for the number of payments to be made, and we have 0 as the amount of money that's remaining to be paid. So it means that after 60 payments, we've paid off the loan. And interest. It's all at a zero balance. All right, and then we're talking about the y-intercept. We have 0, 76,500. So again, go back over to your key. When 0 payments have been made, then you still have $76,500 remaining to be paid. So you can rearrange that sentence a little bit so that it sounds a little bit more human and not so robotic. But we could say that 0, 76,500 means before payments are made, or before payments begin, we have $76,500 to be paid. Okay. How should X and Y be limited in the model so that they make sense in the application? So my X, it's going to go all the way over to 60. It looks like we shouldn't be going more than 60, because once we've paid our 60th payment, then it's paid off. So we wouldn't go further than 60. We wouldn't do less than 0 because you can't make negative payments. So X is going to be limited from 0 to 60. We're talking about the window dimensions you would put in on your calculator. And then we also have the Y. The lowest balance that you can have is 0. And the largest balance that you can have is 76,500. You're not going to have a negative balance, and you're not going to owe more than the 76,500. So those are our X limits and our Y limits for your calculator. So we want to use those intercepts to sketch the graph of the equation. So that means we go to our y equals, we type in our equation. It's 76,500 minus 1,275x. There we go. And set our window from 0 to 60. And then on the y, from 0 to 76,500. And when we graph, you'll see the beginning of the loan and the end of the loan, and you can see what happens to the loan balance there. So how does the amount owed on the loan change as the number of months increase? Well, hopefully, we hope that it's going to decrease. Okay. All right. As the X increases, it goes to the right, then the Y is decreasing. So as the months increase, the balance decreases. Slope of a line. And the slope of a line is the number that measures the steepness of the line. The larger the number, the more steep it's going to be. And the closer that slope number gets to 0, the more flat it is going to be. So one definition of slope is that it's the vertical change divided by the horizontal change, or the rise divided by the run. And we actually have a formula for it. If a non-vertical line passes through the points x1, y1, and x2, y2. Its slope is found by using this formula. Now I have students all the time who confuse the formula and get it upside down. So I have a little memory device for you. It's kind of silly, but it'll help you to remember. If you look, the bottom of that equation looks like a picnic table, doesn't it? Looks kind of like a picnic table. And there's our x2 and x1. And then what do you put on top of picnic tables? Of course, you put yum-yums. And so then we say that the yum-yums on a picnic table are mmm. So kind of a silly, fun way for you to remember what the slope formula is so you don't get it upside down. And let's try this with example 4, calculating the slope of a line. Find the slope of the line passing through the points -3, 2 and 5, -4, and what does the slope mean? So we can label this x of the first point, y of the first point, x of the second point, y of the second point. And so we have slope is going to be y2 minus y1 all over x2 minus x1. And then simplify from there. -4 minus 2 is -6. 5 minus -3 is going to be a 5 plus 3. So that gives me a -6 over 8, which is -3/4. And what does the slope mean? Well, this is your rise, this is your run. So we have a rise of -3 that actually means that we're falling if the 3 is negative. So we fall 3 units for every run of 4 units to the right. Okay. Now there's other ways you can interpret this slope as well. You could put the +3 on the top and the -4 on the bottom. That's equivalent to -3/4. So you would rise 3 units and run to the left 4 units. So just make sure that you're only making one negative move if your slope is negative. Negative moves would be going down or going to the left. Positive moves would be going up or going to the right. But if you have a negative slope and you go down and to the left, you're actually going to end up graphing a positive slope because a negative divided by a negative is a positive. So it's consistent with the algebra. All right, find the slope of the line joining the x-intercept point and the y-intercept point in the lone example 3. So what were our x-intercepts and y-intercepts? Let's find those. X-intercept was 60, 0, and y-intercept was 0, 76,500. So we're going to copy those points down, and let's get the slope formula going for these. So we can call this x of the first point, y of the first point, x of the second point, y of the second point. And so I have the slope being 76,500 minus 0 over 0 minus 60. So I have 76,500 divided by -60. And we can put that into the calculator. 76,500 divided by 60, so that's going to be a negative 1,275. And how does the amount owed on the loan change as the number of months increase? The amount owed on the loan changes by that $1,275. It decreases by $1,275 every payment that's made. Remember, that was the number there. So there's a connection to that original equation. So the amount owed will decrease by $1,275. The decrease is connected with that negative $1,275 each month. Nice. And in fact, you pay that $1,275 for 60 months, just like they said. That loan of $60,000 plus the $16,500 interest is going to be gone. All right, slope and y-intercept of a line. The slope of the graph of the equation y equals mx plus b is m, and the y-intercept of the graph is b. We saw that with the slope on the previous question. We have 1,275 when we found the slope between 2 points. The 2 points that we had were the intercepts. So it doesn't matter which 2 points you pick, but we specifically had those, so we use those, and the question asked for us to. And we see that slope right there. So the connection is that this number that's in front of your x is your slope, your rate of change. And how is it that the y-intercept of the graph is b? How do you find y-intercepts? You make the x 0. So if you have this equation and you've made x 0, then we get a y equals b. So then your y-intercept, again, is 0b. Okay. Find the slope and the y-intercept of a line. Determine the slope and the y-intercept of the line here. I have, just by looking at it, it's already in that nice form. My slope is 7. And my y-intercept, it's not negative 12, it's 0, negative 12. Remember, write it as a coordinate because intercepts are coordinates. On this equation, finding the slope and the y-intercept line of the line involves a little bit more work. It's not in the form of y equals mx plus b. But you can go ahead and solve it for y and you'll be set. So let's go ahead and subtract a 2x from both sides. And then divide both sides by negative 3. So I get y equals a positive 2/3 x minus 4. So your slope now we see as 2/3, and your y-intercept is 0, negative 4. Constant rate of change. The rate of change of the linear function is y equals mx plus b. That's the constant m, the slope of the graph of the function. Rate of change describes by how much the output changes, which is an increase or decrease for every input unit. The rate of change in an applied context should include appropriate units of measure. So when we interpret the meaning of the problem, that's when we have to pull in those units of measure to be able to explain what that means for other people who are not taking this math class. Example 6, Hispanics in the United States. Using data and projections from 1990 through 2050, the percent of Hispanics in the U.S. population can be modeled by h of x equals 0.224x plus 9.01, with x equal to the number of years after 1990. What is the slope of the graph of this function? So we can see the coefficient of x. There we go. So the slope is 0.224. What does the slope tell us about the annual rate of change in the percent of Hispanics in the U.S.? Well, first off, it's positive, so that means it is increasing. So the Hispanic population is increasing by 0.224% each year. If you're unsure about the units and the labels on all of that, just go back to the original problem. The percent of Hispanics is modeled by h of x. So we're going to label our points again. The y, or the h of x, that's the percent of U.S. population. Okay, so the percent of U.S. population that is Hispanic. Okay, and the x part is the number of years after 1990. So the number of years after 1990. So we need to go back here. The Hispanic population is increasing by 0.224% each year after 1990. Before then, the trend could have been different. So we do have to qualify that by saying that this is each year after 1990. That's what this model was based on, was the years 1990 through projections through 2050. Revenue, cost, and profit. The profit that a company makes on a product is the difference between the amount it receives from its sales, which is its revenue, and its productions and sales cost. So if we represent the revenue from the sale of X units by R of X, and represent the cost for the production sale of X units by C of X, then the profit from the production and sale of X units is given by this function. P of X equals R of X minus C of X. In general, revenue is the price per unit times the number of units. And cost is variable costs plus fixed costs. So revenue, let's say that your price per unit, you're selling lemonade in a lemonade stand, and it's 50 cents per cup. That's your price per unit. Let's say that you have sold 100 cups of lemonade. That's the number of units. So the revenue that you have pulled in from that is 100 times 0.5, which is 50. $50 would be your revenue then. Your costs, variable costs plus your fixed costs. Well, fixed costs are things like how much did it cost you to build the lemonade stand. You're not going to pay that every day. You're not going to pay that for every cup of lemonade that you produce, okay? That's a fixed cost, a one-time cost. And your variable costs, they vary because it depends on how much you're producing. So if you have enough materials that you make 50 cups of lemonade, then your variable costs would be based on 50 cups of lemonade that you made. If you need to make more, then it's going to cost you a little bit more. So then that cost changes. It varies. Example 7, cost, revenue, and profit. Suppose a company manufactures 50-inch 3D plasma TVs and sells them for $1,800 each. The costs incurred in the production and sale of the TVs is $400,000 plus $1,000 for each TV produced and sold. Write the profit function for the production and sale of TVs. Well, we're going to have to build up to that. First off, let's get a revenue function. So how much money are you pulling in from selling these? If you produce and sell X number of TVs. So they're selling for $1,800 each. So if you make one TV and you sell it, you bring in $1,800. If you make two TVs and sell them for $1,800 each, then that's going to give you $3,600, and so on. It just keeps growing. So our revenue is 18,000 times however many TVs that you make and sell. Your cost, C of X is going to be the cost for making those units. And it says that the cost incurred in the production and sale is $400,000. So that's your fixed cost. It's a flat $400,000 plus $1,000 for each TV. So if you make one TV, it's going to cost $1,000 plus $400,000. If you make and sell two TVs, it's going to be $2,000 plus the $400,000, and so on. So we're going to say plus 1,000 times however many TVs you produce and sell. Now our profit function is R of X minus C of X. So we have the R of X function, and we're going to subtract the C of X function. Make sure that you use parentheses because we want to make sure that we are subtracting the entire cost function, not just the first term of it. So P of X equals 1,800X minus the 400,000 minus 1,000X. Okay, and now we just simplify. P of X is equal to 800X minus 400,000. That is your profit, the revenue minus the cost. Marginal cost, revenue, and profit. For total cost, total revenue, and profit functions that are linear, the rates of change are called marginal cost, marginal revenue, and marginal profit, respectively. In example 8, a company produces and sells a smartphone with revenue given by R of x equals 89.50x dollars and cost given by C of x equals 54.36x plus $6,790, where x is the number of smartphones produced and sold. What is the marginal revenue for this product and what does it mean? So we have the R of x function here. The marginal revenue, remember the marginal revenue, the rate of change is the marginal revenue. So the rate of change is the coefficient of the x. So marginal revenue is $89.50 is the marginal revenue. And what does it mean? It means that we have $89.50 revenue per unit made and sold. Find the profit function. So remember that your profit function is your revenue minus your cost. So P of x is going to be the revenue of 89.50x, and we're subtracting the cost. So we're going to subtract 54.36x and also subtracting the fixed cost of 6,790. Okay, that, or make sure that you subtract that entire function in parentheses. Let's just simplify here. So I have, grab your calculator, I have 89.5 and I'm going to subtract 54.36 and I get 35.14. 35.14x minus the 6,790. That's your profit function. So what is the marginal profit for this product and what does it mean? Your marginal profit is going to be the slope of the profit function. So marginal profit is $35.14 per unit made and sold. Okay. But what does that mean? That's the profit per unit made and sold. But it's disregarding those fixed costs. So apparently you have something going on in your factory that costs you this fixed cost of $6,790 every month or whatever time period we're talking about here. So that could be rent on your building, insurance for your business, wages for all of your employees, so on. Those will not change. Those are going to be your fixed costs. Special linear functions. A special linear function as the form y equals b, where b is a real number, is called a constant function. And we've seen one of those already in this lecture. You go back into your calculator, you can do that again. Y equals 5. Remember the graph was just a horizontal line. Okay, and the slope is 0. You rise nothing, you fall nothing as you run however many units you want to go. So identify the type of function and sketch the graph of the function. Y equals 3. We're going to have a horizontal line that goes through 3. Draw it as nicely as you can. Goes through 3 on the y-axis. And make sure that you draw your arrows at the end to show that it goes from negative infinity to positive infinity. Then we have the special linear function y equals x called the identity function, and the slope of that identity function is 1. The identity function y equals x. Let's go ahead and graph that. Now if we had to make a t-table of points, x, y, you see, if x was negative 2, then y is what x is. If x was 0, then y is what x is. And if x were 3, y is what x is, so 3. So we have negative 2, negative 2, 0, 0, and 3, 3. And you can see our graph is going to be this perfectly diagonal line through the origin, okay? And the slope of that identity function is 1. In fact, if you wanted to find the slope using a couple of these points, you could do that. Let's say if I use the point negative 2, and 3, 3, I put it into the slope formula. Then I could say 3 minus negative 2 over 3 minus negative 2. I get 5 divided by 5, which is 1. Your slope is 1. Let's go back to this one and see why the slope is 0. You could pick a couple of points off of there, and let's say that this is the point 3, 3, and this is the point negative 5, 3. And let's see what that looks like when we find the slope. Slope is going to be 3 minus 3 over 3 minus negative 5. So we get 0 over 8, which simplifies to be 0. On horizontal lines, it doesn't matter where your horizontal line is. Your y's are always going to be the same. Here, y is 3. So since your y's are on top, your yum-yums are on top, they're always going to subtract each other and get 0 on the top, which simplifies to be 0. So that's it. Go ahead and try your homework now.